Hi everyone, this is a short video to demo a class schedule project which will be represented on the FPGA board, which you can see on the screen. FPGA board stands for Field Programmable Gate Arrays. So what you see right here in the screen now is just the default program which is on the board already. And we are, to do our project, we are using VHDL language, which stands for Very High Speed Integrated Circuit Hardware Description Language. And we are using Vivado as a software for our code, software environment. And let's try to program the device. So program. And now the moment we program the device, we can see our classes start showing on the 7-segment screen. And the LEDs here will represent which switch is for which class, and we have the first 5 days from there, Monday to Friday. So this class, which days is corresponding to each class, will light up. Now if we press the first one, the first class will stay on the screen with the corresponding LED, and then we have 5 push buttons here. Everyone have different purpose. So we have the first one is for the class. So if we push it, we will see that it's at 2:30, and it's at 2:30, and it's on Monday and Wednesday. And the second one for the lab, it's at 8:30 on Friday. There is no seminar. This button is for seminar. The top button for the midterm, so if we press it, we'll see that it's October 25th, and it's on Wednesday. December 12th for the final, and it's on Tuesday. Okay, and same thing for all the classes. So one thing to note here, that when we press the second switch, it doesn't do anything, and that because we set a priority in our code, and I will show you that in a minute. Okay, so we have to turn the first one off first, otherwise it will not do anything. So when we turn it off, then the second class will come on the screen with the corresponding LED. Same purposes of the push buttons. Class, lab, seminar, there is no seminar, so it doesn't do anything. Midterm, November 1st, and then final, December 13, and it's on Wednesday. Okay, same idea for the third one. We have a class, we don't have a lab, we have a seminar in this one, and then a midterm, and then a final. And same idea for the fourth class. For this class, it's a little easier because there's only a class and a final. We don't have a midterm for this class, we don't have a lab or even a seminar. So if we turn all of them off, every 3 seconds again we'll have a class which with the corresponding LEDs, and it will keep running. Okay. Before we have a look at the code, let's have a look at the FPGA board we are using. So this is the board. If we go down a little bit in this website, we go to the reference manual. And if we go down here, all the way down, and I will include the link for this website on below the video at the end. Okay, so we see that we have 4 different 7 segments, how they are connected in the FPGA board, and then we have like another figure for how each one of them is connected. Okay, so we have a common anode for each one of these. Okay, and then in order to light up one of the LEDs inside this 7 segment, we have to drive 0 to the cathode for whatever segment we want to light in. Okay, so we drive 0 to the cathode, it will turn on. And the common anode here at the top, we have 4 of them. So because they are driven by 4 different transistors, and anode for these 4 transistors is driven by a common 3.3 volt. Okay, so that means if we want to enable the first one, let's say first from right in my case, okay. So let's say we want to enable this one and let it be on. We have to drive 0 to the AN0, okay, and then 1 for the rest to keep them all. Now, what happens if we draw, for example, let's say we represent number 2, okay? So we decided our cathodes, 0 and 1s, to represent 2 in this figure. If we do that, and then let's say that AN0, AN1, AN2, and AN3, all of them is driving 0, that means all of these will be on, and that means we will see 2 in all of these, and we don't want that. We want different numbers and different letters so we can see an actual name of the class, or we can see the timing or a date. Okay. To do that, I use a multiplexing technique. So I use the rising edge clock, which will change every 0.0025 seconds. So initially starting with setting the when the first clock will like run, we will enable only the first ones, driving 0 only to A and 0, and 1 for the rest. So only the first one is on. Okay, the rest of them off, and in this case, we push the number 2 based on the cathodes to the first. And after 0.0025 seconds, we turn this off. We keep only the second one is on, and the other 3 is off. And then we can push another numbers. Okay, and again every 0.0025 seconds we change the AN0 to 3 one by one, and whenever we change one of them we change the number we want to push. And because 0.0025 seconds is very fast and I cannot affect it, we will have the impression that all of them are lighting at the same time. Okay, so that's the technique we used here. Now let's have a look how we used it in the code. Okay, so this is the code. We will not go over all the code. We'll just go into the basic idea how we use the clock and how we made it run. So if we go here, that's the first clock I'm using. I'm using 2 clocks. I will go to the second one in a bit. So the first clock is here. First clock. It will start. The first clock is 0, so it will keep incrementing. And then whenever it reaches the limit, or it reaches, like, it will be equal to this number, then we'll move to here where we assign the 7th segment to be incremented by 1. So originally we have a 7th segment arranged from 0 to 3, and initially 0. So it will keep incrementing until it arrives to 3, and then it will go back to 0. Okay, and in this case, because 0 to 3, we have 4 options. We can use this 7th segment to set up which one of the LEDs of the 7th segment LED we want to keep on or off. Okay. So in case 0, originally when we start the clock, we set it to 0. So enabling only the first 7th segment and keep the other 3s off. Okay. When it is 1 after 0.025 seconds, we turn the next one on, see the 0 for the next one, and then the rest will be off, same idea as we increment. Okay, that's how I enable. Okay, and if we have a look at the second clock here, okay, the purpose of the second clock is to use it when all the switches representing the classes are off. So if there is no switches turned on, everything is off, we will be using this switch. And this switch will run, or this clock, sorry, and this clock will run for 3 seconds. So what I'm trying to do by this clock, if all the switches are off, I'll represent one of the class with its days represented by the LEDs. And then after 3 seconds, I'll move to the next class. Okay. And again, because I only have 4 classes, you see the second clock initially to 0, and the LED display is 0 to 3. Okay, because I only have 4 classes, so it's 0 to 3, 4 options. Okay, again, same idea, keep incrementing until 3 seconds, and then set the clock again to 0, increment the LED display, and again do the clock again. Okay, the rest of this code is very basic. It's just combinational logics using cases, else if statements. So I'll not go over all the code right now, but like everything is commented and there is full details on the GitHub link, which is below the video. So if you want to see the logic of the code and the rest of it, you can click on the link and see full details of the project and the code as well. Thank you so much.